All right, so to call or not to call, says students will be using some prior knowledge to make a scatter plot of linear sets of data, determine a rule, and to use this representation to make some predictions. So all of this is kind of a little review of what you did back in Algebra 1. So hopefully you guys still remember a little bit of Algebra 1. All right, so here's what you're going to do. You're actually going to do this on your own for about 10 minutes here, and then we're going to take a look at some of the answers that you guys come up with. So the scenario we're working with is that a cell phone company requires customers to pay a set fee for every call, plus an additional charge for every minute that they use the phone. The cost information is summarized in the chart. So for example, if they talk for 1 minute on the phone, you're going to have to pay 32 cents. If you're on the phone for 2 minutes, the cost is 44 cents. For 3 minutes, it's 56 cents. For 4 minutes, it's 68 cents. For 5 minutes, it's 80 cents. And for 6 minutes, it's 92 cents. So what you guys are going to do for me is there's 4 questions. You're going to work on those 4 questions on your own for about 10 minutes. And then I'm going to see what you guys come up with. The first one is all you're doing is taking this data and creating a scatter plot. Make sure you label each the x and the y axis for me. Tell me what they represent and what you're going to count by. If you want to count by ones, that's fine. If you want to count by twos, make sure it goes with the data. Just make sure you can fit all of these points on your paper. Once you've got the scatter plots, then you're going to go to number 2, which is to determine an equation that would relate these x and y values. And how you do that, that's going to be up to you. I'm not going to say anything just yet. For number 3, you're going to tell me how much a customer would expect to pay for a 15-minute call. And then finally, number 4, if they charge $1.52 for a call, how many minutes did she talk on the phone? So what you're going to do is answer these 4 questions for me. Again, I'm going to give you about 10 minutes, and then I'm going to call for some of you to share your answers with me. All right? So let's go ahead and get started. 10 minutes, and then we'll go from there. Again, when you're doing your scatter plot, guys, tell me what the x and y axis represents. Tell me what you're counting by. And then start plotting the points. You get stuck on one of the questions, don't let it hold you back, skip it, answer some of the other questions, then come back to it, maybe something will click. at this point, if you haven't been able to figure out number one, skip it, try one of the others. Probably the hardest question you're going to come across on these four is probably number two, guys. However, even if you don't get the answer to number two, it is still possible that you can come up with the answers to 3 and 4. So don't let one question hold you back. Give you guys a few more minutes and then we're going to start looking at these. All right, start wrapping it up because I'm going to be calling some of you guys up here to share your answers with us. when I call you up there, I'm not looking just for the answer, but I'm looking for your thought process. What did you do to come up with that answer? So make sure you're ready to explain how you came up with your answer. The whole thing. Remember, the equation has an equal sign. So it should be an equal sign. All right, we're going to go ahead and start looking at some of your answers. Remember, the idea here is to figure out or see how much you guys still remember from your Algebra 1 days. Some of you remember quite a bit. I noticed some of you remember a few little tricks that you were taught back in Algebra 1. Very good. Some of us, we don't remember too much. It's too far back for some of you guys. All right, so let's see how we did. First one, I'm looking for the scatter plot of this data. All right, so let's go ahead and start with code. And if you need to take your paper up there, guys, that's fine. Yep. Now remember, Cody, you're identifying or labeling the X and Y axis, what they represent. You're showing me what you're counting by, and then I want to see your scatter plot. There you go. So the Y is the cost of the coin, and that's going to be the number of minutes. Okay, very good. So if you didn't do that, make sure you include that. Then we're going to do, okay, so he's counting by ones for the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so the X values he's counting by ones. Okay, so he's counting 0.10, 0.20, 30, 40, and gotta get a little extra practice running on the board. All right, so it looks like he's counting by 0.10 or 10 cents. 10 cents, 20 cents, 30 cents, 40 cents. All right, so now you're going to go and start plotting the points. So you got 1 and 32 cents. There you go. That's all right, as long as you're close there. The next one is 2 and 44 cents. 4 cents. 30 and 56 cents. All right. Looking good. The last one was 692. All right, and it's kind of hard to do it, but yeah, that is pretty much it, guys. Again, if you didn't label what the X and Y values represent, make sure you do that. This is the cost of the call, and the X values represent the number of minutes. All right, so did anybody else get that same exact graph there?
Yeah,
right. Now notice he counted by 10 cents. Did anybody use something different besides 10 cents?
I just started at 30, went up to 40, went up to 50.
All right. All right, so you counted by 25. So there's nothing wrong with that as long as you got the points in the correct spot. So this is only one vertex. There's several others. I noticed some people, maybe you counted by 20 cents, 20 cents, 40 cents, 60 cents, and so on. As long as you're consistent, that's fine. All right, let's go and take a look at the next question, which is, what's the equation that would represent the X and Y values? All right, so this one's a little bit trickier. So, Jessica, come on up here and share your equation with us.
I don't have an answer.
You don't have any answer? All right, well, let's try Brian. Give us your equation and tell us how you came up with that. By the way, there are several different ways that we could have come up with this equation. Y equals 12x plus 22. All right, and can you tell me how you did that? And what, when you say calculate, what exactly did you do when you calculate?
Put in that, edit, put all that in there.
Very good. And then what? Once you had it all in your calculator, then what did you do?
Go to the side and go to the right.
Go to the right? Very good. So some of us remember that little trick from Algebra 1, the stat button. As a matter of fact, let's go ahead and do this, guys, because we're going to need this here in a minute anyway. So if you don't know how to do this, let me show you how to do it right now. Go to stat in your calculator. Very first choice you see there is edit. So select that first one, edits. In L1, what do we put in L1, by the way? X. So in our case, the 1, 2, 3, 4, 5, and 6. In L2, we're going to put the Y values, which in this case are going to be the 32 cents, the 44 cents, the 56 cents, 68 cents, 80 cents, and 92 cents. So go ahead and put all those values in point. Again, this is under Stat Edits. Of course, if you type in any of those numbers incorrectly, we're going to get the wrong answer. So be very careful when you type in those numbers in. Now, once you have all those numbers in, we did what? Go back to Stats. But then you have to move to the right where it says Calc. And the one we use is number 4, linear regression. So once you hit that number 4, they're going to give you two numbers, a value for A and a value for B, which in this case would have been the 0.12 and the 0.2, which is how we came up with the equation. So we can use that stat button anytime we have a table of data to come up with a linear equation using the linear regression. Now, if you look closely, does anybody spot where this 0.12 is coming in the table?
Because when you add them,
Yeah, notice what's happening here. It increases each time. How much is it increasing each time? 0.12. So where the heck is this 0.2 coming from? Anybody figure that one out yet? This equation is written in this form right here. Anybody remember what that form is called? Again, this is all Algebra 1. This is called the slope-intercept form. And why do they call it the slope-intercept form? Because this number represents the slope. This number right here represents the what? The y-intercept. So what is this number right here? It's the y-intercept. It's our starting point. We start off charging us 20 cents. After that, it just increases by 12 cents each time. All right, so that was the equation. Now let's take a look at some of the other ones. Number 3. How much would a 15-minute call cost? All right, let's see here. Let's get Samantha. Go up there and show us your answer and how you came up with that answer. What was the answer and how did you get that? How much would it cost? 15-minute call. Remember, guys, there's going to be more than one way to come up with this answer. All right, so she's got $2.36. Anybody else get $2.36 for their answer? Uh-oh. Okay, I'm curious. How did you come up with $2.36? It obviously came up somewhere. Where did that come from? I want to know what's going on in your head.
Third grade, we had to put in this number, do that, and I just like put the calculator. So it was like oh my god.
And actually, and if you did that, guys, if you continue the pattern, we should still get the same answer. We've had that happen last period as well. Some people, all they did was extend their table. You'll notice there's a pattern up here in the X. You got 1, 2, 3, 4, 5, 6. So obviously the next one would be 7, 8, 9, 10, 11, 12, 13, 14, and 15, right? So you can extend it all the way to 15 minutes. You can go ahead and continue with the pattern here. What was that pattern again? Increasing by how much? 12 cents. All right, so if you increase it by 12 cents constantly, we should get the correct answer. Maybe you just were off a little bit here. What was the correct answer? $2. Did anybody do it that way where you just extended the table? All right, that is one option. But there are a couple of other ways, and I didn't even think of that way, but there are two other ways. Anybody know another way we could have got that same answer?
But like the linear regression in your stat thing, the y equals, and it just goes.
Check that out. Everybody go to y equals. Remember we just came up with the equation? Let's type that equation into our y equals. And that equation was y equals 0.12x plus 0.2. Put that in your calculator. Once you got that in, go to your table. Second graph. Go to your table. And what you're going to see is this same exact table with many, many, many other ordered pairs. So what do you see right next to 15 in your calculator? You see your $2 here. So that would have been a second option. There's a third option. Anybody got a third way to work this?
You just erase that number.
What? What was that equation again? It was this right here, wasn't it? What was the x's representing again? The number of minutes. So why not just replace x with a 15 for 15 minutes? What am I going to get if I put that in my calculator? You're going to get your $2. So we could have also worked this out algebraically. But of course, in order to do that, you would have to have the equation first. Obviously, if you didn't have the equation, this is probably not the route that you went. But you still could have come up with the answer too. All right, let's go to the last one here. A little bit backwards on the last one. This time, they gave you the cost, $1.52. We want to know how many minutes were they on the phone. All right, so let's go with Jasmine. What did you get? Write that down for me and tell me how you came up with your number. So we know how much they're charging. What we want to know is how many minutes were they on the phone. So what did you come up with? Very good. 11. And how did you get that number?
I did the y equals, put that equation in there, just scroll to.
Okay, so very good. She had the equation, so she put it into y equals, and then looked at the table, and right next to that $1.52 was sitting me 11. Was that the only way to come up with that answer? No. Some of you extended the table, as we mentioned earlier, did it that way. We could also take that same equation we were working with earlier, and since this time they gave us the cost of $1.52, we could have simply replaced y with $1.52, and then we could have solved this for x algebraically. So again, this is going back to our Algebra 1 things. All right, so that wraps up the call or not to call. What we're going to do now is we're going to go on to the next one, which is what's my function? What's my function? All right, so it says here the students are going to be analyzing linear functions from 3 representations, tabular, graphical, and verbal. This is what we're doing on what's my function. So you'll notice here on this assignment, or this handout, there's 4 questions. We're going to work on 2 of them together, and then I'm going to let you try 2 on your own. So make sure you all follow along, because the 2 that you do are going to be very similar to the 2 that I do. All right, so here we go. The first one. A function contains only these 5 points: -2, 3, -1, 1, 0, -1, 1, -3, and 2, -5. First of all, they're telling me that this is a function. How do we know that this is a function?
X's don't repeat.
Yeah, the x's aren't repeating, therefore we know it's a function. So the first thing we're going to do is we're going to graph this function. We're going to plot each of those 5 points. So here we go. Let's find -2, +3. Put a point there. Now we're going to go down to -1, +1. That's right here. The next order pair we have is 0, -1. Then I have 1, -3. And then finally I have 2, -5. Now don't get carried away, guys, because all they gave me was 5 points. That's it. So am I going to connect all of these dots?
No.
No. Do not connect the dots, because they only gave me 5 points, and I only want to show those 5 points on my graph. If I connect the dots, I would be including a lot of other points that aren't written down for me, so don't do that. All right, so now that we have it graphed, part B wants to know, is this graph continuous or is it discrete? Well, first of all, in order to answer that question, you got to know what these words mean. So continuous. Anybody remember what that one was?
When you had the line.
When the points are connected. Discrete means when the points are not connected. And that's on our word wall over here. Okay? That's continuous and discrete. In this case, if the dots are not connected, we're going to call this discrete. Anytime we have individual points or points that are not connected, it's called discrete. C, is this increasing or is it decreasing? Decreasing. Why? Because it's going down. Notice the pattern is going down. As the x values get larger, the y values are getting smaller. Next, they want me to identify the domain and range of this function. So let me start with domain. Help me out. Domain. Is that the x or is that the y? X. So what we're going to do is we're going to list the x values. All right, here we go. X values are -2, -1, 0, 1, and 2. That's our domain. Those are the x values we have in this function. Very similar for the range. Range is the y values. All we're going to do is list all of the y values. And those y values are 3, 1, -1, -3, and -5. That's it. Domain and range. What are the x's? What are the y's? E. What equation relates the x and y values in this function? What equation can I use to describe this set of ordered pairs? Well, not just y equals x, but you're part right. It's y equals something. What is that something? Well, look, guys, we have a set of ordered pairs. On that one that we just did earlier, didn't we also have a set of ordered pairs? And how did we do the equation there? We used what in our calculator? There was a button, stat. So that's what we're going to do here. Everybody go to stats. Then go to edits. Remember, the x values go under L1, the y values go underneath L2. Make sure once you get all your values in, that you are using number 4 for linear regression. By the way, guys, when you're typing in, and be very careful. You're typing in each of these ordered pairs. And obviously, if you type in one ordered pair incorrectly, the whole equation is going to be out. So be very careful. What was that? Y equals -2 x plus -1 or just a minus 1. Same thing, right? All right, so the equation we're looking for here on E is y equals -2x minus 1. Now, guys, before I go on to that last question, I want you to notice something. That equation that we just came up with, y equals -2x minus 1, look at this set of data. Look at the points. Did I really need to go to my calculator to get that equation? No. Because what does this number in front of the x represent? It represents the slope. Can I find or look at these points and determine what the slope is? Yeah. What's going on with the dots to get from one dot to the other? Notice all I'm doing is going down 2 and over 1, which means my slope is -2. What does this -1 at the end represent? It's the y-intercept. And what is the y-intercept here? It's a -1. So, this equation that we have here, we could have simply got that looking at the ordered pairs or the graph. We didn't really need to go to the stat button. All right, next one, F. How does the domain of the represented equation compare with that of the function? Domain. Domain is the x. What is the domain of this equation? Go to your calculus. Go to y equals. Y equals and type in -2x minus 1 and graph it for me. Does that graph on your calculator look exactly like what I have here? Do you see 5 dots on your calculator? No, you see a line. What is the domain of that line? What are the x values on that line? All real numbers. There's lots of them. There's a lot of negatives. There's a lot of positives. So the domain for this equation here is all real numbers. Is that the same domain that we wrote down over here?
No.
No. So there's a huge difference between the equation and the function that we have here. So here's what I want you to write down for me on F. The domain for the equation. The domain for the equation is all real numbers. And guys, remember, we do have this notation we can use for all real numbers. The domain for the equation is all real numbers. for the equation. It's all real numbers. But the domain for the function, is, and then all we're going to do is write down these numbers that we had earlier. Okay, so -2, -1, 0, 1, and 2. So the domain for the function is -2, -1, 0, 1, 2. So if you stop and think, that's a big difference. The domain for the equation has lots and lots and lots and lots and lots of x values. But the domain for our function, did we have lots and lots and lots of x values? No. How many x values did we have in our function? 5. That's it. We only had 5. So there's a huge difference between the equation and the function itself. All right, so that takes us through number 1. You're going to see one very similar to that here in a minute. Let's go on to the next one, number 2. Here it says that a phone company is charging $29.99 per month to use their service and network. In addition, they charge an extra 12 cents per minute, or a portion of a minute, for a call. The first thing we're going to do is we're going to write an equation that relates the number of minutes. We're going to use X to represent the number of minutes with the month charge, and we're going to use Y to represent the month charge with the telephone company. So here we go. Y equals, in other words, the monthly charge equals what? How do they charge? What are they charging you for? Well, first of all, they charge you no matter what, how much? $29.99. No matter what, every month you're going to get charged $29.99. Is that the only thing they're going to charge you? What else? Plus 12 cents per minute. How am I going to do that? 12 cents per minute. What do I need to write? 0.12 x. We're going to use x because they did tell us x number of minutes. All right, so this is the equation that we're working. Y equals $29.99 plus 0.12x. Now, that is one version of the equation. We could also do this. We can have those two numbers switch places and write the equation as y equals 0.12x plus $29.99. That's the same equation, guys. So what's the difference? The only difference is this one that's in green is written in the slope-intercept form. That's the only difference. All right, so now that we have the equation, let's go ahead and answer the 4 questions. Is this increasing or is it decreasing? What do you think? What's that? Increasing. Why would you say increasing? Why would it be increasing? What's getting bigger? The numbers. Every time you're on the phone, what's happening to the monthly charge? It increases. The more you talk on the phone, the more they're going to charge. C. Would you consider this function to be continuous or discrete? What do you think? Very good. Continuous. That is continuous. D wants to know what is the domain and range of the problem situation. I want you to underline this part for me here. The problem situation. Let me start with the domain, the x values. What kind of x values do we have in our problem situation? First of all, the x, what do they represent again? Yes, it is the domain, but what do the x's specifically represent? Read A. What does it say? X is the number of minutes. Okay, so keep that in mind, guys. We're talking the number of minutes. So what kind of x values do we have if we're talking number of minutes? Can I say all real numbers? What does all real numbers mean? It means all the negatives and all the positives. That's what all real numbers means. What's wrong with that? Why can't I say that? Oh, what? You're going to say it? Say it. You can say it? All right, say it again. X is greater than or equal to 0. Why? That's right. You cannot be on the phone for negative 5 minutes, can you? Can you be on the phone for 0 minutes? Yeah. Can you be on the phone for 1 minute, 2 minutes, 3.5 minutes? Sure. But you cannot be on the phone for negative minutes. Okay? So that's why our domain has to be greater than or equal to 0. What about the y values, the range here? Well, first of all, what do those y values represent? They represent the month's charge, or how much they're charging you per month. So let's think about this. What kind of y values are we going to have? Or what kind of monthly charge are we going to have? Can I have negative values there? Can you have a bill of negative 20 bucks? No. So what do we know about our y values? What kind of numbers do they have to be? Positive numbers. However, am I going to say y is greater than or equal to 0? Why not? What? So no matter what, even if you don't use the phone, they're going to charge you how much? $29.99. Is the cost ever going to be below $29.99? No. So the y values are always going to be larger than or equal to a $29.99. Your cost will never fall below that. Even if you don't talk on the phone, you're still going to get charged that monthly service charge. All right. E. How does the domain and range of a problem situation differ from the represented equation? In other words, how does this compare to the domain and range of that equation there? Well, let's go to our calculator. Let's go to y equals. Type that equation in for me. So y equals. Type in your equation. 0.12x plus 29.99. Look at your graph. Look at your graph. You don't see your graph? Why not? Anybody know why we can't see the graph? Because it's $29.99. What's wrong with that? It doesn't fit on your calculator, right? Because your window that you're working in is not big enough. But you can also look at your table. Go to your table, second graph. Remember, domain and range. Those are the x and y values. Over here we said the x values were greater than or equal to 0. But if you look in your calculator, do you see only positive x values in your table? No. You also see what? Negatives. What about your y values? Do your y values in your table start at $29.99? Well, at 0, but what about on those negative numbers? Yeah. So notice here the domain and range, and I need you to write this down for E, guys. The domain and range for the equation, is all real numbers. It's kind of like what we did for F on the previous question. The domain and range for the equation is all real numbers. But the domain and range for our problem situation is this right here. The domain and range for the problem situation is what we wrote down for you. So again, the domain and range for the equation is all real numbers, but the domain and range for the problem situation was this over here. So again, huge difference. When you're talking the equation, and usually, guys, when we're talking about our linear equations, your domain and range is going to be all real numbers. All right, so that wraps up the first two. We're not done, or you're not done. What you're going to do is you're going to turn the page, and you're going to see two more questions that are very similar to the two that we did together. You're going to work on number 3 and number 4. Number 3 and number 4. You're going to work on those two for me. No, right now.